Due to a severe crankshaft failure in the engine and the absence of suitable replacement parts locally, the car owner had no choice but to seek out a highly skilled elderly gentleman with expertise. He employed traditional methods to repair the crankshaft. Since the crankshaft is a precision component within the engine, the masters had to first measure the two halves of the crankshaft before proceeding with the traditional repair. As traditional methods involve the use of a lathe, the master could securely fix the fractured side onto the lathe. Since the four-jaw chuck lacks self-centering ability, the master had to use a scraping needle for measurement, ensuring concentricity. Once the concentricity was established, the master could then commence the cutting of the fractured surface of the crankshaft. To facilitate proper alignment with the other half of the crankshaft, the master had to cut the fractured surface flat and then use a lathe tool to create a locating hole. This hole served the purpose of aiding in the auxiliary fixation of the irregular crankshaft using a top needle. Following the auxiliary fixation, the master proceeded to chamfer the end face of the crankshaft, aiming to create a slope that would enhance the welding strength on the fractured surface. After completing the chamfering process, the elderly gentleman could now use a larger tap to enlarge the locating hole. Opening up this hole was essential for the convenient alignment of the two halves of the crankshaft. Once this side was properly machined, the process could continue. Following that, the master could proceed with the machining process on the other side. The cutting process on this side was similar to the previous one. Due to the relatively long length of this crankshaft side, the master had to use a scraping needle for measurement, locate the copper core, and use a center frame for auxiliary fixation. Once properly fixed, the master could then cut the fractured surface. Firstly, the master had to flatten and smooth the uneven fractured surface, using a tap to create a center hole on the fractured surface for easy fixation using the tailstock top needle. After fixing with the tailstock top needle, the master could use a lathe tool to cut the fractured surface. As the other end of the crankshaft had already been drilled to create a circular hole for alignment, this side needed to be cut to form a small cylindrical part for alignment. To prevent excessive cutting, the master measured the dimensions of the circular hole on the other side and used a micrometer to measure the small cylinder. After the master's meticulous cutting and precise measurements, the small cylinder was finally cut. At this point, the two sections of the crankshaft could be aligned. With the assistance of the small cylinder and the circular hole, the alignment was relatively easy. The most crucial step was the angle of the crankshaft, and although it wasn't detailed, they may have marked it in advance. After a meticulous alignment, the crankshaft was finally aligned. Then came the most crucial step, welding the crankshaft. At this point, it was the turn of the skilled eyeglass-wearing gentleman to complete the physical task. Before proceeding with the welding, he needed to ensure the concentricity of the two crankshaft sections. The eyeglass-wearing gentleman used a dial gauge to measure the crankshaft and, after confirming the measurements, proceeded with the welding. Due to the high temperature heating from the welding rod during the welding process, the crankshaft would inevitably undergo deformation. The eyeglass-wearing gentleman had to simultaneously measure and weld using the dial gauge, making corrections with a small perpendicularity tool if needed. Controlling the temperature during the welding process was crucial, as too low a temperature could affect the welding strength, while too high a temperature could result in crankshaft deformation. After meticulous welding and measurement for over half an hour, the crankshaft was finally welded. The next step involved precise cutting of the welding surface of the crankshaft. At this point, there might be some lingering questions about whether the shaft diameter would shorten after the crankshaft repair. Just as the audience might be wondering, the eyeglass-wearing gentleman surely anticipated this concern. If the repair was unsuccessful, it would be detrimental to the reputation of the repair shop, which relies on both technical expertise and word of mouth. Following the master's careful cutting of the shaft diameter, the crankshaft had finally been successfully repaired.